What is the basics of USB 3.0, 3.1, Gen 1, 3.1, Gen 2 versus that of today's standard USB 2.1 interface? So with this introductory understanding of what we deal with USB interfaces, we have to first understand the generations of USB. A long time ago, many years ago, there used to be something called USB 1.0. It didn't last very long on the markets, and if you were an IT guy back in the day, they were kind of cumbersome because they were almost plug and play. But then came USB 2.0. And you know this because if you look at USB 2.0 interfaces, they have a black edge on the interface where the actual metal contacts are. USB 2.0 provides basically about 480 megabits per second transfer rates. So for those styles of devices, that was pretty decent. When you're working with such a stick, you mostly got these because they had capacity, not necessarily because they were super fast. But that all changed with the standard of USB 3.0. And you will know this because if you look at the actual 3.0 interface, it has a bright blue contact, which matches, in cases of hubs and switches for USB outputs, the same color coding. Now, with that being said, you still have some other standards about USB 3.0 on up, which is different than that of USB 2.0 and down. Here is an example of a USB 3.0 standard hub with a USB 3.0 USB memory stick with an output, and this is surprising, but it is actually out there, a Type A connector, but with a bright blue plastic fan line inside it, allowing you to connect your USB 3.0 cables up to your basic USB 3.0 port. Connecting USB 3.0 still acts just like USB 2.0 in every regard, especially if you're using an A to an A male cable interface. That's important, but it's very critical that you get the blue class cabling because of the wire classification inside the housing itself. You see, the reason why that's the case is that USB 3.0 needs a bandwidth of 5 gigabits per second. That's quite higher than 480 megabit. But USB 3.1 Gen 1 can actually pump that up even a little faster. And Gen 2 of USB 3.1, it goes all the way up to 10 gigabit per second. Very, very fast transfer rates. But there are some problems with USB 3.0 standard cable sets. So you basically have two standards of USB 3.rev cables that exist. You have the A to A connections, which show you on both sides of the blue interfaces, but is very compatible with many devices that are out there. Then you have the true standard, which is a very well shielded cabling. Again, the blue. But your B connector, well, what we would call a B connector. This is actually a 3.0 interface for a 3.0 hub only, or a 3.0 device only. It will not take anything else, and it doesn't want anything else. That's why it's a little different in comparison to a standard USB 2.0 B connector that you would see for like a printer. And as you can see, not compatible even if these Type A's were blue. So when a case like that happens, you have to source out this cable. So in this order that you see here represents basically the sequence of speed. The small 8 gig module here is a USB 2.0 standard and is capable of basically providing 480 megabits baseline. You can have specialized USB interface 2.0s that have some additional caching on, which actually can speed them up to some degree. Now the USB 2.0 PS2 trick does get you up to about 1.5 to 1.2 gigabit per second, utilizing more copper in the connectivity. But the USB 3.0, 3.1, and 3.1 Gen 2 all reach between 5, which is the 3.0 gigabit per second, up to 10 gigabit per second to Gen 2. That's an impressive amount of speed. Knowing and understanding that USB 3.0, 3.1, both are at 5 gigabit, is important to remember. But the principle is still the same. The last thing that's important to understand, and this may surprise you, but really not, is the USB standard industry guideline decided that they were going to go out there and redesignate USB 3.0 as USB 3.1 Gen 1. At that point in stage, it is because of a reclassification only, and principally the 3.0 and 3.1 Gen 1s are pretty much the same. There is a little bit of a super speed USB functionality, but it's a theoretical speed. It's really not very practical. So 5 gigabit per second is an average for 3.1 Gen 1 and USB 3.0. USB 3.1 Gen is quite a different beast altogether because it's a next-gen specification guideline with super speed USB output, and that puts it in the 10 gigabit range, or roughly 1.2 gigabytes per second. With that being said, this concludes the basics of the USB 3.0 standard. Now there's one last little bit of surprise information. Your USB 3.0 hubs. Now the hubs are just as interesting and somewhat misleading as other hubs that are traditional 2.0. With this particular hub, it requires what is called inline power. So if you're going to do bit mining with a hub like this, it's not going to work well. Don't do it. The reason why is because it's only going to get about an amp to 2 amps max to run this hub from your motherboard or from your laptop. A power assist hub would actually come along with the specialized blue and type B class USB 3.0 interface cable, and it would be supplied at a minimum of 4 amps. But if you're going to get a good hub that's going to have lots of outputs, or if you're going to do bit mining, do some more research and get closer to 5 to 8 amps if you can. They cost a little bit more, but the return will be more beneficial. If you're going to bit mine with USB 3.0, be advised that it's not really a great platform yet for Moonlander 2s or the SAS 256 based USB interfaces because of the way USB 3.0 works. It's better if you're going to mine to use the USB 2.0 hubs with a higher amperage output. They seem to work much better that way. I know that from personal experience. But this is the lesson on USB 3.0. I hope you guys enjoyed it. If you like the video, just click like. Thanks. Bye.